So let's dig a little deeper into sort of how we're going to implement some of those functions or those features. First of all, we have to protect the data that is used by the operating system or the trusted computing base. It must protect itself. Remember, one of the requirements we had is that it should be tamper-proof. So no one should be able to tamper with it, and that's only possible when it is able to protect itself against that kind of tampering. So let's talk about some security features of the trusted operating systems that you have in terms of protecting data and other kind of resources. Okay, so one thing that we address in these kind of systems is what is called object reuse protection. Think of various kind of objects or resources, memory pages, for example, disk blocks. So what happens, you allocate a memory page to one process, that process completes and then goes away, and then that page is allocated to a different process. Well, what happens if that page had some sensitive data that belonged to the first process? This also applies to disk blocks for persistent data. Okay? If when a file is deleted, we may free up certain blocks where the file data was stored, and these free blocks are free to be assigned to somebody else, and they could be, but there may be data already in these blocks. In fact, there is. One thing we can do if we are concerned about having trust in a system is that when a process is allocating either disk blocks or memory, then we should be aware of the fact that something could be left behind in these reusable resources. Well, what can we do? If something is left behind, if the system is trusted, it can zero out these objects before they get reused. So before the memory block is given to the new process, to make sure that it doesn't have access to the data that was stored in that memory block or page by the last process, we can zero it out. If we're talking about file deletion or data that's written out on the disk, we can overwrite it with various patterns of zeros and ones. And we have secure deletion, for example, and that's basically writing it one or more times with some garbage or random zeros and ones to make sure that the old data that was there is no longer there. And you can sort of carry it even further. For example, when you discard your disk, you actually destroy it, you degauss it, or you do physical destruction. Because one of the things that was reported a number of years ago, a bunch of students at MIT actually went to some place and bought some old PCs at almost no cost and then pulled out the disks in those machines, and they contained all kind of sensitive data. Because even if either people don't delete files, even if you delete, if we are not doing some of these things we discussed here, which a trusted system should do, the data would still be there, and if the disk gets in the hands of somebody else, then they will be able to sort of gain access to that data. So if you're building a secure system, you have to worry about this idea of reuse of objects or resources, in particular memory objects, disk blocks, and how information that's stored in them by a given process or the system has to be wiped clean before those resources are reallocated to somebody else.